Okay, so for this video, what we're going to be doing is we're going to be kind of breaking down how to solve a copper and aluminum cell. So the first thing that we're going to do is we're going to assign one of these electrodes to be copper and the other one to be aluminum. And it doesn't matter which one we assign which. So what I'm going to do here is I'm just going to simply say, you know what, this one's going to be copper, and this one's going to be aluminum. Again, it does not matter whether I pick the left or the right. Sorry, give me 1 second here. All right, sorry about that. Okay, so here we go, copper and aluminum. So what I'm going to do next is I'm going to find copper and I'm going to find aluminum on my activity series. So here I see, here I see copper and here I see aluminum. Now, based on this, I will know that copper is going to be reduced and aluminum will be oxidized. So copper is going to be reduced and aluminum is going to be oxidized. Therefore, the half reactions that are occurring, okay, I can copy the copper one just off of the chart because that's a reduction half reaction. So Cu2 plus 2 electrons, okay, is going to go to copper metal. All right, now aluminum, all right, it's oxidized, so I'm going to write the reaction in the opposite direction. So I'm going to have aluminum, okay, because I need to lose those electrons, goes to 3 electrons. Sorry, here, 3 electrons, plus Al3 plus. Now note here that we don't have equal amounts of electrons. So what's going to happen is for every 2 electrons that copper releases, I'm not going to quite have a full oxidization. Okay, so that means technically that copper is going to have to do this 3 times for every 2 times that aluminum does its thing. Okay. Okay, so oxidized means that this is the anode. Okay. Reduction means this is the cathode. Therefore, this is the positive side, this is the negative side. Electrons flow from A to C. So the electrons are flowing in that direction. Now, here we go. What you need to keep in mind is we're always going to have copper or like copper ions in a copper anode. So we know we're going to have some Cu2 plus in here, and we're going to have some Al3 plus in here. Okay, now the question is what is going to happen. So when I look here at the reduction half reaction, I'm going to see here that what's happening is the copper is going into, or sorry, it's coming out of solution and it's being plated as copper. And that makes sense because I'm going to have 2 electrons coming in here and plating that. Okay, so what's going to happen is I'm going to have a buildup or an increase of the SO4 minus, sorry, that'd be 2 minus, that's in solution. Okay, so what's going to happen there is I'm going to have this increase in it because I'm pulling out the positive cations that are in solution. So now I look here at the oxidization and I see that the aluminum metal is actually breaking down, okay, into Al3 plus. So what's happening is I'm going to have an increase in the Al3 plus concentration, not in the SO42 minus. So that's going to stay the same. And so this is also going to give up my 3 electrons here. Okay, so what's going to happen now is I have something in my salt bridge, and let's just say that I have KOH. It doesn't matter what we say we have in the salt bridge, so long as we have a positive and a negative. So in this case, I'm having a buildup in my solution over here of negative ions. So K plus, or the positive cations, are going to come down in this direction. And then because I'm having a buildup of positive ions over here, I'm going to have the OH negative, or the anions, are going to come over here on this side. All right, so that pretty much sums up everything that's happening here in this particular cell. Note a few things I think I said incorrectly here, because the aluminum is going to be giving up 3 electrons here. That means like 1.5 of these can be happening, and I think I said it the other way around earlier. So just to clarify that. In addition, keep in mind, I believe I used a different salt here for my salt bridge. It does not matter what salt you use or what ionic compound, so long as there's a positive and a negative and you know which way that's going. All right, so thank you very much for watching this particular video, and let me know if you have any questions.